Hi, this is Pavitra. Today in this session, let us know about thermistor. Okay, what are all the few important points that we are going in this session are listed below. The first one is what is thermistor or definition of thermistor. The second, how they appear, how the appears of the thermistor. The third one is type of thermistor. The fourth, uses or the applications of thermistor. The fifth and the last one is differ from other devices. The thermistor, how it is differ from other devices. These are all the points that we are going to discuss in this session. Okay. Let us go on to the first one, that is called as definition of thermistor or what is thermistor. Okay, the thermistor is also called as thermal resistor. The thermistor is also called as thermal resistor. Here we are going to know what do you mean by thermal resistors. Here we are going to identify the two important word that is called as thermo and resistor. Right? This thermo is nothing but temperature. The resistor is nothing but the opposition to flow of current is called as resistors. Here in case of thermistor or thermal resistors, we are correlating these two words. Thermo and resistor leads to the formation of thermistor or thermal resistors. Then definition, we have to define the thermistors now. So definition or what is thermistor means, a thermistor is a thermally sensitive resistor that exhibits a precise and predictable change in the resistance of proportional to a small changes in the body temperature. That is, if the small changes appears in the body temperature, that will predicted in the resistance that is directly proportional to that of a thermal or a temperature, that is called as a thermistor. Or we can define this thermistor in the another way, that is a thermistor is a resistor whose electrical resistance varies with the change in temperature. If the temperature of the circuit or a temperature of a device changes, whose electrical resistance also varies. It may be proportionally or maybe an inversely. It leads to the next one. Next, here thermistors is defined like that the thermal and resistance are correlated to each other, and overall review is it is a device which exhibits a relationship between the thermal and resistors, that is called as a thermal resistors. Then let us know a brief about the history, how it is came from, who invented this, when, where. Okay, so in 1833, Michael Faraday scientist discovered this thermistor. Okay, Michael Faraday discovered these thermistors. The Michael Faraday goes on a research about the semiconductors of silver sulfides. Okay, while going the research conducted on the semiconductors like silver sulfides, he observed that the temperature varies with that of a resistance. That is in case of inversely proportional. Let us all discuss in the next type cases. Okay, in silver sulfides, he observed that the relation between the temperature and the resistance, there he discovered the thermistor, a device called as a thermistor. Next, how the symbol appears to be. The symbol of this device is appears to be like this. Here we are written the diagram of this symbol of the thermistor. We are going to connect these two ends to that of a circuit, external circuit, that for a external calculations. But this is the circuit or the symbol of that of a thermistors. The next one is called as appearance. How this appears, this thermistor, how it is appears, how it is look like. The thermistors appears in the form of bead. Here I have shown it is in the form of a bead, it is in the form of a disc, or it may be in the form of the rod. It looks like manufacture of these thermistors is in a different form. It may be a bead form, or maybe a disc form, or maybe a rod form. Which one we require? For the requirement, it is prepared or it may be manufactured. From which are the materials is this bead, disc, rod or manufactured? These are all manufactured from the metal oxides. These are all manufactured from metal oxides. Which metal oxides? The magnesium, it may be nickel, cobalt, copper, etc. Like these type of metal oxides we are going to prepare the toffee, these thermistors. Then let us know about how we are going to prepare this. In what manner we are going to prepare this means, this magnesium, nickel, cobalt or copper, they are taken to be in the form of a powder. These powdered form materials or powdered form metal oxides are heated up. The process is called as scintillation. Listen here, the process of heating these metal oxides is called as scintillation, and these all metal oxides are heated to form a masses. That masses leads to the formation of bead, disc or in the form of rod, which we required. For the requirement, we are going to appear or going to prepare in different manners by using this metal oxides by the process called as a scintillation process. Okay. And the next point is types. What are all the types of thermistor? Okay, thermistors are generally defined, or types are generally called as two types of thermistors. One is called as PTC and another one is called as NTC. This PTC is called as a positive temperature coefficient. I repeat once again, PTC is called as positive temperature coefficient and NTC is called as negative temperature coefficient. These are the two types of thermistors. The first one, PTC. What do you mean by PTC or positive temperature coefficient? Means here the temperature increases along with the resistance also increases. That means temperature is directly proportional to that of a resistance. In case of PTC, positive temperature coefficients, these temperature and resistance are directly proportional to each other. If the temperature increases, the resistance also increases. If the temperature decreases, resistance also decreases. It is in case of positive temperature coefficients. Then let us move on to NTC, negative temperature coefficient. Here in negative temperature coefficient, the temperature is inversely proportional to that of resistance. Temperature is inversely proportional to that of resistance. If the temperature increases, resistance of a material decreases, or maybe vice versa. Vice versa means the resistance of a material increases, the temperature decreases. This is called as negative temperature coefficients. Then positive temperature coefficient and negative temperature coefficients are used for the different manners, but in the most of the cases we are using the NTC thermistors, negative temperature thermistor coefficients thermistors, because where we are going to discuss about the heating or cooling effect, there we are using the negative temperature coefficients. Then where we are using PTC, positive temperature coefficient, a few of the uses or the few of the applications, example like fuses, we are using the PTC, positive temperature coefficients. In the fuses, they are related to each other. If the temperature increases, the resistance of a material increases. So applications of PTC in fuses and NTC are mostly in case of heating and cooling effect we are going to discuss that one. Next, how they appears if we are going to plot a graph of resistance versus temperature. If we are going to plot of resistance versus temperature in case of PTC and NTC, how they appear to be. Okay, we know that resistance of a material increases as the temperature of the material increases. While the temperature of the material increases, the resistance of a material also increases. This is called as PTC. Okay, next, how this NTC graph appears means the resistance decreases as the temperature increases, or as the temperature decreases, the resistance increases. See here, I am going to decrease the resistance of a material as there is a increase in temperature. This is called as NTC. So NTC and PTC or appears in these form on the when we plot a graph of the temperature versus resistance. Okay, PTC and NTC, they appears to be like this. Next point is uses, where the thermistors has been used, because the thermistors has a wide varieties of application in the recent days. Where we are going to use means, first one, they are used in cars. In cars, where we are using in cars means, in the cars it measures the oil, how much the oil is there, oil measurement, we are using the thermistors. Or maybe a coolant temperature, what is the coolant temperature, is to measure the coolant temperature, we are using the thermistors. In case of ACs, we are using thermistors. Generally we know that nowadays we are using most commonly we are using ACs. If we want to set a room temperature for about 20 to 25 degrees Celsius, then what is the activities of these thermistor means, if the room temperature is increases beyond that setting temperature, then it automatically ons the AC. Otherwise, if it is below that temperature, then it is automatically off this ACs. On and off of the AC will be carried out by using this thermistors. Next, in case of household applications like ovens or maybe a refrigerators, where to set that of a temperatures, we are using this one. Next, the digital thermometers, while measuring that of a temperature, we are using this. Again, last one, rechargeable batteries. While recharging the battery get heated up. To decrease this temperature, the resistance has to be activated. For these cases, we are using the thermistors. For these are the uses or the applications of thermistors. There are wide and varieties of application. This is the few we are discussing in this class. The last one is called as different from other devices. We know that in the recent days there are many devices which are going to do the same activities as like that of thermistors, but how it is differ from other devices in case of RTDs, resistance temperature devices, ICs, integrated circuits, how these are all same activities, but how it is differ from that of thermistors means, the thermistor are very compact one compared to these of materials. They are compact one, and the second one, these are low price, that is cost efficient. These thermistors were cost efficient compared to that of other devices, and the response of these thermistors are very fast, that is in a few seconds it will respond. In all the cases in RTDs and ICs, this is very low response, but in case of thermistors, the response is very quickly, and it is also durable one. It remains for a longer years compared to that of RTDs and ICs. So we are using mostly the thermistors other than that of RTDs or IC. So in this class, let us discuss that thermistor and how they appears, types of thermistors, uses, how it is differed from that of other devices. Okay, thank you.